In this very lesson, we shall be looking at expressing recurring decimal as a common fraction. Expressing recurring or repeating decimal as a common fraction. But remember, we are still on the real number system. In our previous lesson, we learned about recurring decimals and we were able to give examples of such numbers. We said that recurring decimals are decimals that repeat or recur infinitely. Examples of recurring decimals or repeating decimals are 0.3333 up to infinity. So we said that this is a recurring decimal. We also learned how to rewrite this in a very short form. We said that the number 0.333, which rounds up to infinity, can be written as 0.3 dots. So whenever you see this means that this number is a recurring or repeating decimal. Another example of a recurring or repeating decimal is 1.252525 up to infinity. So this is a recurring decimal, and we can shorten this or rewrite this as 1.25 dot dot or 1.25 dash. This means that the number 25 is recurring or repeating. Another example of a recurring decimal is 3.641 up to infinity. So you can see that with this number, the number that is recurring or repeating is 641. So we can rewrite this as 3.641 dot dot or 3.641 dash. This means the same thing. Now looking at the first recurring decimal, looking at this, how many digits repeat? You can see that it is only 3 that is what repeating to infinity. Now when we look at the second recurring decimal, you realize that the number 25 is repeating infinitely. So the number 25 repeats. Now when you look at the third recurring decimal, you see that the number 641 repeats infinitely. So the number that is repeating is what? 641. I guess you are following. Now, with the first part, how many digits are repeating? It is only one digit that is repeating, and that digit is what? 3. So it is only one digit that is repeating. With the second example, how many digits are repeating? It is only 2 digits that is repeating. So it is what? 25. Looking at the second example, how many digits are repeating? We can see that it is only 2 digits that is repeating, and those digits are 2 and then 5. Similarly, with the last example, we can see that it is only 3 digits that are repeating, and those digits are 6, 4, 1. I guess you are following and you understand it very clearly. Now, in expressing recurring decimals as a common fraction, we are going to follow some few steps to guide us in doing that. So let's look at the steps that are written on the board. So the first step says that represent the decimal number by any variable and call it equation 1. So the decimal number that you are to convert or express it as a common decimal, you represent it by any variable at all. Any variable at all, and then you call it equation 1. Then the second step says that identify the number of digits that repeats in the decimal part. If 1 digit repeats, multiply equation 1 by 10. If 2 digits repeats, multiply equation 1 by 100. If 3 digits repeats, multiply equation 1 by 1000 in that order and call it equation 2. Subtract equation 1 from equation 2, and lastly, you solve for the variable. So let's take our first example and see how best we can solve or express a recurring decimal as a common fraction. So we have our first example. We have to express 0.6 dot as a fraction. 0.6 dot as a fraction. So we know that 0.6 dot is a recurring or repeating decimal. So we can write 0.6 dot as 0.666 up to infinity. Then after that, we move on to the steps. Now the first step says that represent the decimal number by any variable and call it equation 1. So in doing that, you can choose any letters of the alphabet A, B, C, D, E up to letter Z. You can represent that with any variable at all. Now I'm going to use S. You can use any of the letters, but for uniformity's sake, let's all of us stick to the variable X. Okay, so let's all of us use the variable X. So we are going to let X is equal to what? 0.6666 up to infinity, and then we call it equation 1. Then after that, the second step says that identify the number of digits that repeats. If 1 digit repeats, multiply equation 1 by 10. So we are going to identify the number of digits that repeats. So looking at this, how many digits repeat? It is only 1 digit that is repeating infinitely. So it is only 1 digit that is what repeating, and that digit is what? 6. So because 1 digit is repeating infinitely, we are going to multiply equation 1 by 10. So we multiply equation 1 by what? 10. So 10 times S, and then 10 times 0.6666 up to infinity. So 10 times S will give us 10x. 10 times 0.666 will give us 6.666 up to infinity. And then we call it what? Equation 2. Now the third step says subtract equation 1 from equation 2. So we have equation 2 minus equation what? 1. So we have 10x minus x. Then we have 6.66 minus 0.66. Remember, they all run to infinity. So we have 10x minus x will give us 9x. Then we have 6.66 minus 0.66 will give us 6. Now, with this, since those numbers behind the decimal point, they all run to infinity. When you subtract them, you are going to get 0. So 6.66, then this 6.66, let's take it that all of them will cancel because they all run to infinity. So we are left with what? 6 minus 0 giving us 6. I guess we are following. Good. So we are looking for s. We divide both sides by 9. Both sides by 9. Now we cancel 9. We have our s is equal to what? 6 over 9. But I guess we can break it down, right? So we have 3 into 6. We have what? We have 2. And then 3 into 9. We have 3. So we have our s is equal to 2 over 3. Very, very easy. Now, always when you are done, you can cross-check it with your calculator. So you can punch 2 divided by 3 on your calculator. You press equal to, you press SD. It will give you 0.66666 in that order. I guess you are following. Let's take our next example. So this is your example. Pause the video, you try your hands on it. You have to express 0.42 dot dot as a fraction. So let's solve it together. So we have 0.42 dot dot. This tells us that the number there is recurring or repeating, and the number that is recurring or repeating is what? 42 to the kingdom count. So we know that 0.42 dot dot is the same as 0.424242 infinitely. Then we are going to let any variable, let's say x, equal to the number that is what? Recurring. So we have 0.424242, and then we call it equation what? 1. Very good. Then after that, we identify the number of digits that repeats. So how many digits repeat? It is only 2 digits that is repeating infinitely. So because 2 digits is repeating, we multiply equation 1 by 100 from the steps. If 2 digits repeat, multiply equation 1 by 100. So we are going to multiply this equation by what? 100, because 2 digits are repeating. So we have 100 times what? X is equal to 0.424242. So we simplify. 100 times x will give us 100 what? X. And then, 100 times 0.4242 will give you 42.4242. And then we call it equation 2. Then after that, we subtract equation 1 from what? Equation 2. So we have 100x minus what? X is equal to 42.4242 minus what? 0.4242. All of them last to infinity. So 100x minus x will give us what? 99x. And then 42.4242 minus 0.4242. Since those numbers behind the decimal point, repeat infinitely, when you subtract them, they'll go to 0. So those numbers behind the decimal point will cancel, meaning they'll go to 0. Then you are left with 42 minus 0 giving you what? 42. We are looking for the variable x. We divide both sides by 99, both sides by 99. This and that will go. We have our x is equal to 42 all over what? 99. Do you think we can break it down? Yes, we can reduce it to its basic form. 3 into 42 will give us 14, right? Good. And then 3 into 99 will give us what? 33. Therefore, our s is equal to what? 14 over 33. So as I said earlier on, after everything, you can cross-check it with your calculator. You can point 14 over 33 on the calculator, and it is going to give you 0.424242. So thy kingdom come. We will take our last example. It is your example. Pause the video. You try your hands on it. So you have to express 1.25 as a common fraction. As a fraction. Express 1.25 dot dot as a fraction. It is your example. So we have 1.25 dot dot. We know that the number is recurring because of these two dot dots. So 1.25 dot dot is a recurring decimal. And then we can rewrite this as 1.2525 till thy kingdom come. Then after that, we let any variable, let's say x, equal to the number that is recurring or repeating. And then we call it equation what? 1. Very good. Then after that, we identify the number of digits that repeats. So how many digits are repeating? We have 2 digits, and those digits are 2 and then 5. So because 2 digits are repeating, we are going to multiply equation 1 by 100. Very good. So we are going to get 100 times x. Then we have 100 times 1.2525. We simplify. 100 times x will give us 100x. 100 times 1.2525 will give us 125 point what? 2525. Now remember, the number 25 is recurring infinitely or repeating infinitely. So you can write as many as you want the 25. Then after that, we subtract equation 1 minus equation. We subtract equation 1 from equation 2. So we have 100 minus x. Then we have 125 point what? 2525 minus what? 1.2525. All of them recur infinitely. So we have 100x minus x will give us what? 99x. 125.2525 minus 1.2525. Now, since the number 25 recurs or repeats infinitely, they will run, when you subtract them, they will go to what? 0. So those numbers behind the decimal point, these two numbers, since they run up to infinity, when you subtract them, you are going to get what? 0. So now you are left with what? 125 minus what? 1. So you have 125 minus what? 1. And that is what? 124. So let me write it. We are looking for the variable x. We divide both sides by 99. Both sides by what? 99. This and that will go. Now we have our x is equal to what? 124 all over 99. So as I said, you can always cross-check it with your calculator. Good. Now I'm going to give you some tutorial set questions. Pause the video. You try your hands on them. Okay. So this brings us to the end of today's lesson. Can you pause the video? Write them down. You try your hands on it. See you next week. Bye bye.